When you're multiplying a polynomial by a monomial, we did it lots first semester, and we were referring to it as a distributive property. The difference here is instead of just having a number out in front of our parentheses, we're going to have a variable and a number. Maybe the variable will have an exponent on some of the problems. So it makes it a little bit more complicated. We got to use the rules we learned in section 8.1 about when we're multiplying variables together. If they have the same base, we're going to add their exponents. Remember, coefficients are just going to work as they always have. You're multiplying two numbers together. You're just going to write down the result. Okay, also, if they happen to have different letters, like we're going to see below here, if there's an x times a y, we're just going to write them side by side. Don't change their exponent at all, just and write them alphabetically. For instance, a w is going to come in front of an x, and x is going to come in front of a y. That'll really help you when we get to combining like terms. So some of these problems you'll just do the distributive property, some of them you'll have to do the distributive property and then combine like terms afterwards, kind of combining what you're learning right now in 8.6 with the previous section of 8.5. So when you're taking x squared times 5x to the fourth, it might help you think of the invisible one there, just kind of get your head around the coefficient. So 1 times 5 is 5, and x squared times x to the fourth is x to the 6th power. Repeating that rule of in a multiplication, add your exponents together. Second multiplication was out in front of the parentheses times your second spot, so 1x squared times 7x to the first. You come up with 7x to the third, that invisible 1 and the 2. Might even help if you write it down. This is a reminder for yourself. And a third multiplication, x squared times, in this case, always think of a subtraction sign belonging to a number and it being a negative. So I'm going to say this is x squared times negative 2, which is just negative 2x squared. When you're writing your answer, anything that comes out as positive, write as addition. Anything that comes out as negative, write as subtraction. And you're done with the problem already. You can just glance at it for a second. You realize none of them are like terms. They all have an x, but on that x is a different exponent each time. Thus, you can't add or subtract anything and come up with a new term. So we multiply, there's a trinomial on the inside. You end up with a trinomial in your answer when you're just doing this distributive property, unless you're able to combine like terms somewhere. Scroll down for this example 2. Same concept, gets a little more complicated. You have a coefficient on your variable outside, and then we also have more than one letter happening. We got x's and we got w's. Just handle it kind of piece by piece, and it won't be too overwhelming. So negative 3 times 12 gives you negative 36. And your x to the fourth and x to the third, add your exponents together, x to the 7th power. Second multiplication, negative 3x to the fourth times 7x squared. Just multiply and see what you come up with. You will get a negative 21, right as a subtraction. Combine your exponents into a 6. Third multiplication. I like things as a negative 3 times a negative 1. Just kind of prevent errors, really take your time with those. First off, you end up with the positive 3 and x to the fourth times w to the first. The exponents aren't going to be combined, and preferably you can get in the habit of writing these variables alphabetically. It'll really help you out later on, and we can all agree on an answer without having to debate too much whether it has the same meaning. Okay, each individual piece either has different letters or different exponents, thus none of them can be combined. That's your final answer. On number 3, before you get started, it might just help to write down some of these invisible exponents, that way you don't go too quick and make an error. So 8xy times 13xy to the fourth. 8 times 13 is 104. You get an x squared with your exponents and a y to the 5th power when you add them together. There's only 2 multiplications in here, since there's only 2 spots inside the parentheses. Multiply, get a positive 72, right as an addition. Not the best 7 I've ever made. And you come up with an x to the 13th power. And even though there's not a y attached here, you still need a y in your answer. Things don't have to be like terms. They don't have to have the same letters in order to multiply them. Double check you can't combine anything, and you can move on. Just each individual multiplication is not going to be too difficult of things. Just take it piece by piece on these problems. I'm going to give myself a little more room to work on number 4. Focus on the first multiplication. You come up with a negative 20. They're different letters. Their exponents aren't going to change, and W comes first alphabetically in front of your Y. Second multiplication, say positive 24. And W comes in front of your X. These last two terms are not inside of the parentheses, so they're not part of the multiplication. You're just going to have to copy them down beside the work you've already done. Just bringing those straight down, not changing anything at all yet. Okay, then this is a problem we will be able to find like terms. So we got a w squared y to the 9th power. Look in the problem, there's also a w squared y to the 9th power in this spot. Okay, now we're back to adding things together. So just add their coefficients, negative 20 and negative 8. Subtraction sign really belongs to that coefficient. Comes up with a negative 28 w squared y to the 9th. Exponents aren't changing now that we're just adding things together. They were changing before when we were multiplying. Okay, continue to look for like terms in this spot. Let's say w squared x to the 4th, and on the end we have a w squared x to the 4th. This coefficient is 24. This coefficient, if you think of it being an invisible negative 1. So 24 plus negative 1 gives you 23. Exponents are not going to change. I'll keep saying that to kind of drill it into our heads. So we multiplied twice, multiply their coefficients, add their exponents in multiplication. And when we're combining like terms, just double check they have to have the exact same variables and the exact same exponents in order to add or subtract. So we can go a little bit further on problem 4 on the screencast than we could in the previous ones, just because we found some like terms after we were working. Problem number 5. We're going to do 6 examples overall in this screencast. Problem number 5. Take your multiplications one at a time. 6 times negative 3. Lots of times I've seen kids in the past just they see the 6, they see the negative 3, they add them together. Remember, a distributive property is a multiplication. You got a number on the outside of the parentheses. You're going to be multiplying, so be careful with it. Come up with a negative 18 when you multiply. X to the 2nd and x to the 2nd. Add them together. Come up with the x to the 4th power. This invisible 1 combined with your 5, make a y to the 6th power. And move on to the second multiplication. Take this times the second spot in your parentheses. Helps you think of the invisible 1 being in front of your variable, go for it. You multiply, you get a positive 6, adding exponents, x to the 5th, and we still need that y attached. The negative 7 x to the 5th y behind it is not part of the multiplication, not inside the parentheses. Just copy it down. Okay, I like when I'm working problems, just kind of working left to right. There's an x to the 4th, a y to the 6th. I scan through these. They all have different exponents. I'm just going to copy that down in my final answer. Okay, I look in the second spot, x to the 5th, y to the 1st. Third spot, x to the 5th, y to the 1st. These can be combined. That is a 6 and a negative 7. You can think of it 6 minus 7 or 6 plus negative 7. Either way, you come up with a negative 1, x to the 5th, y to the 1st. Exponent's not changing when it's an addition problem. And if you don't want that 1 written there, it's not absolutely necessary. It's really up to you. There's your final answer. Is a binomial. It has 2 terms. We were able to combine like terms on this problem. About the most difficult type of problem you're going to face in this section is when you have to do distributive property twice in the same problem. That's what we're facing on problem number 6. Do 2 individual distributive properties and combine like terms if you find any. Outside, it's just a 6. There's no variable connected to it, so this distributive property is something we could have done in our first semester. multiply, get negative 18, and there's nothing here that's going to change our variables. Second multiplication, come up with 24. And once again, variables aren't going to change. It stays 24x to the fourth power. Okay, if we cover up that first parentheses mentally, this is a negative 2xy in front of our parentheses. So we're really multiplying by a negative number. Negative 2xy times x. Think about adding these invisible exponents. Negative 2x squared y to the first. And a final fourth multiplication in this problem. Negative 2xy times negative 1 x to the third. Negative 2 times negative 1 is a positive 2. So one way we can make a mistake if we go in too fast. Mess up that sign. X to the first, x to the third. Add your exponents together if you're multiplying. And we still need that y attached. Y to the first power. And just look back through your problem. There's an x squared y, and here's an x squared y. Go ahead and combine those. It's a negative 18 plus a negative 2. Sign in front of it belongs to it. That gives you a negative 20. Exponents and variables are going to stay the same. We have a 24x to the fourth power. The only other term we haven't dealt with has an x to the fourth and the y to the first attached to it. So they're really different variables involved. We cannot add them. Just bring it straight down. 24x to the fourth, not going to change. On the end, this doesn't match any other terms in our problem. Just bring it straight down. It's not going to change. So we were able to combine two of our terms, but not all of them. Once again, if we were grading this, the textbook might display the answer in a different order. It could be true of any of these problems, especially when we're combining like terms. It might put a 24x to the fourth written first as the highest exponent on an x, tied with the 2x to the fourth y. Most likely you would find a negative 20x squared y on the very end of the problem. It has the smallest exponent on the x, but it doesn't necessarily make your answer right or wrong. It's just, that's an easy way, easy rule to try and get a lot of our answers to look the same. So you can take the time to reorder it. It wouldn't hurt you, but you're going to end up with a trinomial regardless. That's all. Just if you can remember, when you're multiplying, multiply coefficients and add your exponents. But when you're ready to combine like terms, just adding or subtracting, exponents do not change in that case. The only thing you'll do is combine the coefficients. Be careful with signs and you'll do fine.